You're welcome back. Alright, so we're going to continue from where we stopped. Now this time around we are going to be looking at the solution of simultaneous differential equation using Laplace transform. Alright, the difference between this equation and the one that we solved previously is just that in this particular equation we are solving for two variables. As you can see in this example, okay, we're going to solve for y dot and of course x dot. Okay, so two variables, x and y. All right, so the initial condition or the initial value is given at t equal to 0. I have x equal to 0 and y equal to 0. So we are going to also go through the same step. All right, so for each of these equations we are going to write the Laplace transform of each of these equations, starting with equation 1. So let's start with the Laplace transform of y dot. You know exactly what it's going to be. So the Laplace transform of y dot is going to be x y bar, of course that is x raised to the power of 1 y bar, minus then x reduces to the power of 0, which makes it 1. Then I now have y0, of course, plus the Laplace transform of x, which you know already is x bar, equal to the Laplace transform of the exponent of t, which of course is 1 all over x minus 1. So we'll call this equation 1. Then for equation 2 we do the same thing. So exactly, what we did here. So what I'm going to do for x dot, the Laplace transform of course is going to be x bar, right? X bar, then of course minus x0 minus the Laplace transform of y, which of course is y bar, is equal to the Laplace transform of the exponent of minus t. That's going to be 1 all over x plus 1. So this becomes my equation 2. Inserting the initial value, all right, at t equal to 0, x is equal to 0. That simply means that x0 is equal to 0 and y0 is equal to 0. So these two are zeros. Okay, so I have to only write x y bar, then minus x bar is equal to 1 all over x. Okay, 1 all over x minus 1. All right, this still remains my equation 1, and I'll do the same for the other. Of course, this is x bar minus y bar equal to 1 all over x plus 1. And here I have equation 2. So how do I solve these two equations simultaneously? So let's go by elimination. So I will have to eliminate y bar so that I will find the expression for x bar. So for me to eliminate y bar, I have to make sure that y bar have the same coefficient in equation 2 as equation 1. So that simply means that for equation 1, I'm going to multiply by just 1. Okay, nothing changes. Then, but for equation 2, I'm going to multiply equation 2 by x, so that I'm going to have x y bar. Okay, let's do that. So equation 1 multiplied by 1, of course, this is going to give me x y bar, then of course x bar 1, okay, equal to 1 all over x minus 1. So this time around I can call this equation 3. Okay, so now multiplying equation 2 by of course x, I will end up having x squared, then of course x bar, then minus xy bar equal to, multiply the right hand side by x, I'm going to have x all over x plus 1. So here, this becomes my equation 4. So for me to eliminate, uh, of course, for me to eliminate y bar, simply, all I just need to do is to add equation 1. Okay? Equation 1 plus equation 2. Because xy bar plus minus xy bar will give me 0. Okay? So that simply means that y bar is gone. So I'm only left with s square x bar, and of course minus x bar is equal to, I will do the adding. I also add the right hand side, which of course is going to be equal to 1 all over x minus 1, then plus x all over x plus 1. All right, can we proceed? Yes, we can. So of course, taking the taking x bar out as a common factor, I have s square minus 1. Of course, simplifying this fraction, which um, I'm going to do by, okay, of course, I'm going to cross x plus 1 multiplied by 1. That will give me x plus 1. Then, of course, x multiplied by x, that's going to be x squared. Then x multiplied by minus 1, that's going to be minus x. All right, so as you can see, x minus x is 0. I'm left with s squared plus 1. So invariably now, the expression for x bar is going to be equal to, of course, s squared plus 1, then divided by bracket open x minus 1, x plus 1. So bring this one down here, all right? Bring this down here. That's going to be s square minus 1. Now, as you can see, s square minus 1 is difference of 2 square. Okay, this is the same as x plus 1 and of course x minus 1. Okay, this is difference of 2 square. So bringing it down here, I'm going to write it as difference of 2 square. So x plus 1 and of course x minus 1. Okay, so now don't forget that the solution to this equation is simply finding the inverse Laplace transform of both sides of the equation. Okay, but before we can actually do that, okay, so let's actually split this into partial fraction. So how do we do that? Now look at this denominator here. I have x plus 1 times s plus 1. That is going to be s plus 1 squared. So I'm having s squared plus 1, okay, divided by, at the denominator, I have, of course, x minus 1 times s minus 1. That's x minus 1 square. All right. Then, of course, x plus 1 then square. Okay, so I'm splitting this into partial fraction. So okay, I actually believe that this partial fraction will not be a problem. Okay, this partial fraction of repeated power. So let's start with a divided by, I'll have to start with the very first power of x minus 1. That is a divided by x minus 1, the first power. Okay, raised to the power of 1 plus b. They will now move to the second power, right? That's going to be x minus 1 square. Okay, I'm done with this. I'll now have c raised to the power of the first power of x plus 1. Of course, that's going to be x plus 1. Then plus d this time around, the second power of x plus 1, which of course is x plus 1 all square. All right. So you know exactly, of course, this is equivalent to, okay, so you know exactly what we are going to do to the left hand side. Of course, I'm going to divide by the LCM of the denominator, which is still going to be x minus 1 square, and of course x plus 1 square. So let's start dividing. S minus 1 divided by s minus 1. I have just s minus 1. That's going to be a into x minus 1, just one factor. Then multiply by x plus 1 square. Okay. Then plus s minus 1 square divided by what I have in the denominator. So s minus 1 square will cancel the whole of s minus 1 square. So I have b into x x plus 1, s plus 1 square. Then plus c. S plus 1 cancel one factor of this, so I have c into x minus 1 square, then of course x plus 1. Then the last but not the least, d. S plus 1 square definitely will cancel s plus 1 square, so I'm left with this factor. So this is going to be d into x minus 1 all square. So at the left hand side of the equation, I'm still left with s square plus 1, then divided by s minus 1 square. Alright, then of course x plus 1 square. So we know exactly what is going to happen here now. This will cross, this will cross. Alright, so if that happens, so we end up having x squared then plus 1. So end up having x squared plus 1. So equal to, alright, of course, a into x minus 1, okay, x plus 1 square, plus b into s plus 1 square, plus c into x minus 1 square, then of course x plus 1, then plus d into s minus 1 all square. Okay, so we are going to find the value of some variable. We are going to find their value by simply eliminating other variables. So that simply means that looking at the brackets, okay, it is possible for me to eliminate the bracket that has x plus 1. Or let me start, it's possible for me to eliminate the bracket that have x minus 1. If I eliminate the bracket that have x minus 1 by making x to be equal to 1, I'll be able to eliminate a. Alright, of course, I'll be able to eliminate c. Okay, and I will be able to eliminate d. That will help me to find b. So let's do that. So let's start by let me put x to be equal to 1. So that way, a is gone, c is gone, of course d is gone, so I'm left with b. So this is going to be 1 square plus 1, which of course is 2. Okay, it's equal to 1 plus 1, 2, that is of course 2 square. Okay, 1 plus 1 for b, 1 plus 1, 2 square, then multiplied by b. Okay, so with what we have, we can actually conclude, okay, from this that b is 2 all over 4, which of course is 1 all over 2. All right, let's also perform that, that trick again. By this time around, let's put x to be equal to minus 1. That way, we'll be able to eliminate the bracket that has x plus 1. Yes, so we can eliminate a, we eliminate b, then we eliminate c, then we can find d. Let's do that. So putting minus 1, of course, minus 1 into this, that's going to be minus 1 square, which is 1 plus. So this is still going to be 2. So this is going to be 2. All right. So, of course, for d, this is minus 1 minus 1. That is minus 2 square. Minus 2 square is, of course, going to be 4. So I still have 4d. So rearranging this, so d is going to be equal to definitely 2 all over 4, which of course is 1 all over 2. Okay. All right, so there's no other bracket I can eliminate. So that simply means that the other variables, I'm going to solve them by comparing coefficients. I'm going to expand this whole bracket and compare coefficient, okay, of the right hand side to the left hand side. So let's do that. Okay, so let's expand this. So I'm just going to, let's start by expanding this. First of all, this x plus 1. Okay, so x plus 1 square, of course, is going to be s square plus 2x. Okay, please, I'm only doing this. After expanding it, I will clean it and write it down here, okay? So this is more like trying to do the expansion, okay? It's not part of the solution. Do the expansion, then I'll now write the completed expanded um, expression right here, okay? So let's do that. So this is s squared plus 2x plus, of course, 1. So I'm using s minus 1 to multiply. So if I multiply that by x minus 1, x multiply x squared, that's going to be s cubed. Of course, x multiply 2x, that is going to be 2x squared. Of course, x multiply 1, that is going to be plus 1x. Minus 1 multiply x, that's going to be minus x. Okay. Of course, minus 2x, then minus 1. So putting everything together, so I will end up having collecting like terms. Okay. So the like terms I have here is, of course, x minus x, which of course is x minus s, which is 0. Okay, plus x minus, so I'm left with minus 2x. So everything now, if I should, this is going to be s cubed plus 2s squared, of course, minus 2x minus 1. Okay, let's write it down here. So this is going to be a into s cubed, okay, right, s cubed, let me do that well, a into s cubed plus 2x squared, okay, plus 2s squared, then of course s cubed plus 2s squared minus, okay, s cubed plus 2, okay, then of course minus 2x, okay, then of course minus 1. All right, so this is going to be the expansion for the whole of this. Let's go to the other bracket. So this of course is going to be b into s squared plus 2x plus 1. All right, so let's proceed to expanding this. Okay, let me clean this up. All right, so let's expand, of course, s minus 1 square first. Let's do that. So of course that's going to be s squared minus, of course, 2x plus 1. So let's use x to multiply that bracket. X multiplied by s squared is s cubed. This is minus 2x squared, of course, okay, minus x. Use 1 to multiply. 1 into x is x. Use 1 to multiply. 1 into, okay, 1 into s squared is s squared. 1 into minus 2s is minus 2x. 1 into 1 is 1. Okay, so of course collecting like terms. Okay. Collecting like terms. Did I make a mistake? Let me do that again. Please pardon me. Okay. First of all, expanding x minus 1 square. That's going to be s squared minus 2x, of course, plus 1. Using x to multiply, this is going to be s cubed minus 2x squared, of course, plus x. Using 1 to multiply. Okay. This is, of course, plus 1 multiplied by x squared. This is s squared, of course, minus 2x then plus 1. Okay, it's like I made a mistake in this expansion, the one of, okay, but I will find out after I'm done with this. Okay, so let's get this over with. So at this point, collecting like terms, what I have is s squared, of course, minus 2s squared plus s squared. This will give me, okay, let me write it down first. Okay, so this is c, bracket open, s cube, doesn't have any like term, s cube. Then I have minus 2s squared plus s squared, which of course is going to give me just minus s squared. Of course, plus x minus 2x is going to give me minus x. Okay, then of course plus 1. Okay, so let's let me confirm the previous expression, okay, for this brackets. Okay, so I'm having the feeling that I made a mistake right here. So let's do this one more time, expanding this bracket right here. So this is gonna be s squared, of course, plus 2x plus 1. Then using x to multiply, s into this is gonna be s cube, s into this s cube, x into, of course, x into 2x, that's plus 2x squared. Okay, then of course x into 1, this is plus x, using minus 1 to go, minus 1 into this minus s squared, minus 1 into this minus 2x, then of course minus 1. Okay, so this was supposed to be s cube, 2s squared minus s squared, that is s squared, s cube plus s squared. Yes, there was a mistake, s squared. Then of course in this case plus x minus 2x, so this is supposed to be minus x at this point. Okay, then of course minus 1. All right, so that mistake has been rectified. So finally the last expansion, so that's going to be d into, what I'm having there is d into s squared minus 2x then plus 1. Okay, so my left hand side still remain s squared plus 1. Okay, so let's compare coefficient. Let's start with the coefficient of s cube. Coefficient of s cube, let's start, that's going to be a first. That's going to be a, because if I open this bracket, I'm going to have a s cube, so that's going to be a. For this bracket, there's no coefficient of s cube, so I skip it. Then for this bracket, there's of course the coefficient of s cube, that is c. So a plus c, of course, is equal to, there's no coefficient of s cube at the left hand side, so it's equal to 0. This is equal to 0. Okay, so that way, let's see, did we solve for, what did we have before? Okay, we only solved for b and d. Okay, so let's keep on going. Let's go further for the coefficient of s squared. If I carry, okay, if a go into s squared, that is a s squared. So a is one of the coefficient, of course. For the second bracket, b is the coefficient of s squared. All right, for the third bracket, that is minus c s squared. That's going to be minus c, coefficient of s squared. Here, of course, plus d, coefficient of s squared. So let me call this 2. Okay. So now I think with this I can actually solve for some, because already we've gotten our b, we've gotten our d, and from this first equation here, a is equal to minus c. So I think I can solve for a now. Let's do that. Okay, so this is gonna be a, all right, plus b, which we've gotten before, that's 1 all over 2. Then c is minus a. Okay, okay, let's do it this way. A is minus c. Okay, let me just change this to minus c. Since a is, this is minus c. Okay, A is minus C, then of course minus C again, plus of course D, which of course is 1 over 2, okay, is equal to, I've not even put the coefficient, the value for the left hand, the coefficient of S square is of course at the left hand side is 1, okay. All right, so what I'm doing here now is from equation, okay, from equation 2. All right, so this is of course is equal to 1. Half plus half is 1, okay, so I'm having minus 2 minus 2, that's minus 2c, okay, so it's equal to 1. So invariably c, of course 1 minus 1 is 0, okay, minus 2c is equal to 0. Invariably now I can actually have it that c is equal to 0. All right, so that is it. C is equal to 0. Okay, so if C is equal to 0, invariably A is also equal to 0. Okay. All right, we've gotten all that we need for this. So that means in this partial fraction, okay, A and C is not there. We only have B and D. We only have B and D. Okay. So let me extend this. So let's now go to the inverse Laplace transform. Of course, you know very well that inverse Laplace transform of x bar at the left hand side is x is now going to be equal to the inverse Laplace transform of the partial fraction, okay, which of course is b all over x minus 1 square. So what is my b? All right, so what do I have as my b? B is 1 all over 2. 1 all over 2 divided by x minus 1, okay, x minus 1 square. Okay, then of course plus d, okay, d all over x plus 1 square. Let's do that. D is also 1 over 2 all over x plus 1 square. So the question is, what is the inverse Laplace transform of these two expressions? Simple. This can also be written as 1 all over 2 multiplied by, say, coefficient, okay? 1 all over 2 multiplied by. Okay, let's do that. This can also be written as 1 all over 2 multiplied by the inverse Laplace transform, okay, multiplied by the inverse Laplace transform of 1 all over x minus 1 all square. The same thing happens here, okay, okay, so plus take 1 all over 2 as a coefficient, 1 all over 2 multiplied by the inverse Laplace transform of 1 all over x plus 1 all square. Okay, so let's now do justice to this. Okay, so this is no longer x bar, okay? The inverse Laplace transform of s bar is x. All right, so look at this. What do you think is the inverse Laplace transform of this? I know what you think. That is the first shift theorem, right? You can remember. This is actually the inverse Laplace transform of x, but x has been replaced by x minus 1, okay? So invariably, okay? So since it is replaced, so this is going to be 1 all over 2, okay? The inverse Laplace transform of 1 all over x, which of course is, you know what, that's a constant, that is 1. Then multiply by this, the first shift theorem, okay? In which there's going to be the exponent of t, okay? So plus 1 all over 2 Okay, then multiply by, of course, this is also a shift, but the shift is minus t. All right. Okay, so this is the inverse Laplace transform of 1 over x, which is 1. Okay, a constant, which is 1 times 1. Then times the shift, which is the exponent of minus t, because of this plus here. It is the exponent of minus t. All right. So I hope that is what that's. So writing it in a in a normal way, of course, or probably even can just simplify. 2 is the common denominator, or invariably can take it out as a common factor. 1 all over 2, okay, bracket open, the exponent of t, then plus the exponent of minus t. And that is the answer. All right, so please take note of these steps, take note of the procedure. We are going to look at more questions in the next video. So see you in the next video. Thank you very much.